Hi, hello friends, welcome to the channel. In today's session, we'll be saying testing of materials, unit 4, material characteristics testing. Question number 1, the microscopic observation constitutes of. Option A is given as scale of 1 to 100 nanometers. B needs high magnification power. C not visible with naked eye. D contains information about color, luster, shape, composition and structural features. Option number B, all the above. What is microscopic observation? The observation we see in microscopic level. The scale of 1 to 100 nanometers comes under microscopic level. For microscopic observation, for seeing small object in high magnification power. So, option B is also right. Option C, not visible with the naked eye. You can't see a microscopic particle. Can you see a virus? Can you see a bacteria? No, definitely not. With your naked eye. No, you can't see. You need some instrument. So, not visible with naked eye. Contains information about color, luster, shape, composition, structural features. All this comes under microscopic observation. So, I am going with option number E, all the above. Question number 2, macroscopic observation constitute of. What does macroscopic observation constitute of? Option number A, visible to naked eye. Option number B is given as scale of millimeter to kilometer scale. Needs very long magnification of 10 power x. Very low magnification of 10 power x. Option number D, all the above. Macroscopic observation, that means macro means larger particle, bigger particle. Bigger particle is always visible to naked eye. Option number A is right. B, need a scale of millimeter to kilometer. Millimeter to kilometer. Option number C, needs very low magnification of 10 power x. Option number D, all the above. These are the characteristics of macroscopic observation, and this is also observations that can be done on macroscopic observations. So I am going with option number D, all the above. Question number 3, magnification of microscope refers to the amount or degree of visual enlargement of an observed object or enlargement of an image. Option number A is given as true, option number B is given as false. Magnification of a microscope refers to the amount or degree of visual enlargement of an observed object or enlargement of an image. Option A is given as true, option B is given as false. The given magnification of a microscope refers to the amount of degree of visual enlargement. That means magnification is enlargement of an observed object or enlargement of an image. You are enlarging an image and viewing it. That is called magnification. So I am going with option number A, true. Yeah, you can have a small sense that magnification refers to degree of enlargement. That is for an observed object or an image. This is the definition for magnification. So I am going with option number A, true. Question number 4, magnification. Option number A is given as, what is magnification? Magnification A is given as image by object. Option number B is given as image into object. Option number C is given as object divided by image, and option D is given as none of these. Option number A, image by object, is the right answer. Magnification is equal to image by object. For image, how much object you are giving, that is the magnification. Object is resolution. That is the for an particular object, how much you can magnify it, how can you can enlarge it. That is the definition of a magnification. Option A, image by object, is the right answer. Magnification is equal to image by object. Question number 5, resolution is defined as the ability to distinguish two very small and closely spaced objects as a separate entities. I am going to, what is resolution? Resolution is defined as the ability to distinguish two very small and closely spaced objects as a separate entities. I am going to place these two objects. I am placing these two dots. You can clearly define that these two dots are different one. That is the amount of resolution needed to make that these 2 points are two separate ones, not a single point. These are separate points. That is the minimum distance required to that is the ability to distinguish two very small and closely spaced objects as a separate one. These are two closely things. This is two closely, very closely spaced objects. And how amount of resolution needed? How can you that if in 2x you can't say, if 2x it will be looking like this one point, in 4x it will be looking same point, in 10x you can slightly see there is a 2 point, that is a resolution. How the ability to distinguish that two very small and closely spaced objects are as separate entities. This is called a definition of resolution. Then on it is true. So I'm going with option number A, true. What is resolution is determined by, how is resolution determined? Question number 6. Option number A is wavelength of light. Option number B, light gathering power of the objective. Option number C, condenser lens, and option number D, all the above. What is resolution? Resolution is defined by wavelength of light, light gathering power of the objective, condenser lens, all the above. These are all the three other factors to be determined for resolution. So I am going with option number D, all the above. Question number 7. Types of lens used in microscope. In microscope, we will be using objective lens. Option number A is given as objective lens. Option number B is given as ocular lens. Option number C is given as condenser lens. Option number D is given as all the above. The types of lens used in microscope: objective lens, ocular lens, condenser lens will be using in microscope. So I am going with option number D, all the above. Optical microscope consists of dash features. Option A, light source. Option B, minor work in the specimen preparation. Option C, low resolution and magnification. Option D, relatively easy to carry and inexpensive. Option number D, all the above. We have two electroscopes, optical electroscopes and electron electroscopes. Optical electrodes needs light source, that is our normal light. B, minor work in specimen preparation. There is a small little work only in specimen preparation. You have to clean it. That is the only thing you will be doing in specimen preparation. Low resolution and high magnification. You can't distinguish very clearly the particles in optical microscope. It has low resolution and magnification. Relatively easy to carry and inexpensive. You can easily carry it. So I am going with option number E, all the above. All the option A, B, C, D, all the factors of optical microscope, all the features of optical microscope. I am going with option number E, all the above. Question number 9. Electron microscope has dash features. The last question we saw optical microscope's features. Now we are going to see electron microscope's features. Electron microscope has dash features. Light source replaced by a beam of fast moving electrons. Specimen, option number A is given as light source replaced by beam of fast moving electrons. B, specimen is specially prepared and held inside vacuum. The lenses are, option number C, the lenses are replaced by a series of coil shaped electromagnets. Option number D, high resolution and magnification. Option number E, all the above. Electron microscope. This is a high magnification microscope which needs light source should be replaced by fast moving electrons. Option number A is right. Specimen must be specially prepared and held inside vacuum. Here we can't use in the specimen must be kept in vacuum, not in normal air. For fast moving electrons can't move in our normal air. It must be moving. It can move only in vacuum. So the specimen is specially prepared in vacuum. For keeping in vacuum, you must separately specially have to prepare on the medicine specimen, because for electrons and normal specimen cannot be kept in vacuum. For keeping in vacuum, you must specially give some treatments for the specimen. Option number C, lens are replaced by a series of coil-shaped electromagnets. You are replacing the lens with some series of electromagnets in case of electron microscope. Option number D, high resolution and magnification needed. No, it is electron microscope provides high resolution and magnification. Option number E, all the above. All the factors A, B, C, D are the features of electron microscope. So I am going with option number E, all the above. Question number 10. The magnification of optical microscope is. Option number A is given as 500x to 1000x. Option number B is given as 10,000x, and option number C is given as 10,000x. Option number D is all the above. The magnification of optical microscope is between 500x to 1000x. So I'm going with option number A. 500x to 1000x. That is the magnification of optical microscope. The question number 11, the resolution of electron microscope is, option number A is given as 500x to 1000x. That is the resolution of optical microscope. We learned that resolution of electron microscope is much more than optical microscope. So A, definitely A can be. Option number B 10,000 megax. Option number C 50,000x, and option number D 1 lakh x. The right answer is the resolution of electron microscope is 10,000x. So I'm going with option number B, 10,000x. Question number 12. The operational type of optical microscope is, what is the operational type of optical microscope? How it is operated? Electrical. Option number A is given as mechanical. Option number B is given as thermal. Option number C is given as electronic, and option number D is given as radiographic. What is the operational type of microscope? Whether the microscope is mechanically operated or thermally operated, or using heat, or using radiographic some waves or radiations, or it is done in vicinity or in electronic. What is it done? Optical microscope is just a mechanical microscope. It is operational type is mechanical. So I'm going with option number A, mechanical. Question number 13. Operational type of electron microscope is, for electron microscope, what is the operation type? In previous case we saw optical microscope, that is mechanical. So in electron microscope, it's given as option number A is given as mechanical, option number B is given as thermal, option number C is given as electronic, and option number D is given as radiographic. For in electron microscope, we will be using a electronic. The name itself resembles electronic microscope, electronic. So I'm going with option number C, electronic. Question number 14. Microscopic observation includes microscopic observation includes A, optical microscope. Option number B, scanning and electron microscope. This is also called SCM. Option number C, transmission electron microscope. It is also called TEM, field ion microscope. Option number D, all the above. All optical microscopes, scanning electron microscope, transmission electron microscope, field electron microscope are microscopic observations. You can have the last name as microscope. You can guess this answer already, I think. I'm going with option number E, all the above. This all the optical microscope, scanning electron microscope, transmission electron microscope, field ion microscope are the microscopic observations made. So I'm going with option number E, all the above. Question number 15. Macroscopic observations include option A, mechanical testing, option B, differential thermal analysis, option number C, dielectric thermal analysis, option number D, all the above. Macroscopic observation, that is for large particle observation. Option A, mechanical testing, includes hardness testing. In mechanical testing, what all test comes means all mechanical testing. Hardness test, torsion test, shear test, a strength test, a hardness test, Rockwell hardness test, brittle hardness test, that all test includes in mechanical testing. Option number B is given as differential thermal analysis, giving heat and you are measuring its thermal conductivity, thermal resistivity. Then all the thermal factors comes under the differential thermal analysis. In dielectric analysis, for dielectric particle you are giving thermal analysis. That is for all different materials. This is for dielectric. Option number D is all the above. Dielectric means two metals attached in one. That is dielectric. Two metals are fixed in and they form one material. They will have different property, different dielectric properties, different thermal properties. In that materials you will be applying heat on one side and you will be measuring or analyzing how this part is having more damage, this part is containing more, this material, part of material, A part material, B part material is containing. This is a metal workpiece. This is made of two metals, that is one will be aluminum and one will be of steel. You will be placing heat here. You will be heating here. This part of material will be conducting more heat, and this part of material will be conducting less heat. This all will be measured here. This will be bending, this will be some state. That all factors will be getting in dielectric thermal analysis. So I am going with option number D, all the above. All this will comes under microscopic observations. Option number 16, scattered electron is used as a source for. What is scattered electron is used as a source for in SEM or TEM? In SEM only we will be using scattered electron microscope. Just keep some for if you can't remember it, yes. So you are using a scattered electron microscope. Just for this is for only for your remembrance. I'm just saying only this is only for remembrance. The word S for HCM means scanning electron microscope. It's not an abbreviation for scattered electrons, but for just for remembrance sake, I'm saying you scattered electron microscope uses scanning electron microscope uses scattered electrons as a source electrons. So I'm going with option number A, SCM. Just for remembrance, use yes by yes. Question number 17. Transmitted electrons is used as an electron source for option A, SCM, option B, TEM, transmission electron microscope, TT. So I am going with option number B, transmission electron microscope, that is where electrons are transmitted. So I am going with option number B. SEM uses dash energy. Question number 18. SEM uses dash energy. A is given as 1 to 30 kilowatt. Option B is given as 60 to 300 kilovolt. So I am going with option number A, 1 to 30 kilowatt. This is the energy used by SEM. Option number 19. SEM uses dash working process. Scattering, absorption, both A and B, diffraction. Option number C is given as both A and B. Option number B is given as diffraction. Option number D is given as none of these. SEM uses dash working process. It uses scattering, absorption. So I am going with option number A. Diffraction will be used by TEM. SEM uses scattering, absorption. I am going for option number A, scattering, absorption. Question number 20. TEM uses dash energy. Option number A is given as 1 to 30 kilowatt. Option number B is given as 60 to 300 kilowatt. TEM uses 60 to 300 kilowatt. 1 by 30 is used by SEM. So I am going with option number B, 60 to 300 kilowatt. Question number 21. SEM is used in dash environment. SEM is used in, it can be used in air. Option B, vacuum. Option C, both A and B. SEM can be used both in air and vacuum. So I am going with option number C, both A and B. Question number 22. TM is used in dash environment. Option number A is given as air. Option number B is given as vacuum. Option number C is given as both A and B. In TM can only be used in vacuum. So I am going with option number B, vacuum. SEM can be both used in air and vacuum, but TM can be only used in vacuum environment. Question number 23. For scanning electron microscope, specimen thickness must be of any thickness size or typically less than 150 mm. For SEM, specimen thickness must be of any size, can be of any size. So I am going with option number A. For TM, specimen thickness must be of any size or typically less than 150 mm. For TM, specimen thickness must be typically less than 150 mm. So I am going with option number B. For SEM, it can be of any size. For TM, it must be less than 150 mm. Question number 24. The output of SEM will be a 3D image of formation or a 2D projection image of an inner structure. What is the output of SEM? The output of SEM is 3D image formation. Thanks for watching, guys. If you like this video, please subscribe it and like the video. If you are new to the channel, please subscribe it, and thanks for watching, guys. Please share with your friends. Bye.